Welcome to another video by AskMath.com. Let's read the directions to this problem. For each ordered pair, identify whether or not it is in the solution set for the system of inequalities. Given 2x minus y is greater than negative 2, and negative x plus y is less than or equal to 4. The ordered pairs that we're given are 0, 0, 0, 2, and 3, negative 5. A system of inequalities just means that we have two or more inequalities. We have two here, and they're inequalities because they don't have equal signs. They have a greater than sign and a less than or equal to sign, and that makes them inequalities. To identify if an ordered pair is in the solution set just means to take the value for x in the ordered pair and the value for y in the ordered pair and substitute them in for the x and the y in both inequalities. And when you do that, you evaluate the inequality and you determine whether or not the left side of the inequality is in fact, and then you use the symbol, in this case greater than negative 2. If it is, then that ordered pair is a solution for that inequality. And when you do the same for both inequalities, if it works, if it's in the solution for each inequality individually, then it is in the solution set for the system of inequalities. And so what we really have is three problems. One where we're going to be testing the point 0, 0, one where we're going to be testing the point 0, 2, and one where we're going to be testing the point 3, negative 5. Okay, for each of those scenarios, we're going to substitute the values in for both inequalities. So the first one is 2 times x. Now I'm going to replace the x with parentheses because I'm going to be substituting a number in there. Same with the y, greater than or equal to negative 2. I'm going to go ahead and set up my next one as well. Negative, where the x was I use parentheses, plus where the y was I use parentheses, less than or equal to 4. Okay, now three problems, they're all the same problems. The only difference is we're testing each point. So if you want to, just to make sure that you get each problem set up the same exact way, you can go ahead and just set them up right now. It's just a little bit easier to do the same writing right in a row like that. Okay, so now we're going to substitute the x and the y coordinates in for the x and the y in the inequalities. And remember, in the original inequalities, you've got to be a little careful here, but we did have the x's both on the left, the y's both on the right. So these are the x's, these are the y's. Same thing here, same thing here. So I'm just going to go ahead and do that. The first 0 goes in for the x's, the second 0 goes in for the y's. This one, the 0 goes in for the x's, the 2 goes in for the y's. This one, the 3 goes in for the x's, and the negative 5 goes in for the y's. When you do have a negative and a minus sign in the problem, it gets a little tricky to do in your head, so I do recommend, especially for the tricky problems, to write them down on paper. And sometimes you don't realize it's tricky until you've written it down, so if you want to make sure that you get it right, it's usually a good idea to write it down on paper. Okay, so let's evaluate. And remember, when you evaluate, you use PEMDAS, the order of operations, forwards. You could also call this simplify. And there's nothing in these problems happening inside the parentheses, and there aren't any exponents anywhere. But in each of these problems, there is a multiplication problem, and then there is a subtraction problem. And so we do the multiplication first. So let's evaluate this top one. And we've got 2 times 0 makes 0, and minus 0 is greater than negative 2. Is 0 minus 0 greater than negative 2? So 0 is greater than negative 2. If you had $0, that's better than if you had negative $2, right? Negative 2 would be like you owe somebody $2. Okay, so this one is yes. I'm going to switch to blue here so that we can tell the difference between our work and the original problem. Okay, and the next one, don't forget that this is a negative 1 times 0 plus 0, and anything times 0 is 0, plus 0 is less than or equal to 4. Is 0 plus 0 less than or equal to 4? Yes, 0 is less than 4. That's true. And because we have two smiley faces, the ordered pair worked in both inequalities. That means it's a solution to the system of inequalities. Okay, next problem. Again, multiplication comes first. 2 times 0 makes 0, minus 1, and that's a negative 1 times positive 2. And negative times positive makes negative. 1 times 2 is 2. Is that greater than negative 2? So 0 minus 2 is negative 2. Negative 2 is not greater than negative 2. It's equal to negative 2. So that is a frowny face. It is not a solution to that inequality. And because it's not a solution to that inequality, it's not a solution to the system of inequalities. Even if this one worked and we got a smiley face, it has to work for both to be a solution to the system. And so we don't even have to do the next problem. You can if you want, but we already know the answer to the question. Okay, last one. 2 times 3, again multiplication comes first, is 6. And here we've got a negative 1 times a negative 5. Negative times negative makes positive. 1 times 5 is 5, greater than negative 2. Is 6 plus 5, which is 11, is 11 greater than negative 2? Yes, it is. Okay, and negative 1 times 3, negative times a positive makes a negative, and 1 times 3 is 3. And here we've got a positive 1 times a negative 5. Positive times negative makes negative. 1 times 5 makes 5. Negative 3 and a negative 5 make a negative 8. Is a negative 8 less than or equal to 4? Yes, it is. And we have two smiley faces, which means that it is a solution to the system. So the answer to this problem is yes, it's a solution to the system. No, it's not a solution to the system. It was a solution to just one, but not to the system. And the last one, yes, it is a solution to the system. Thanks for watching another video by AskMath.com. Don't forget to check out the rest of the videos at www.askmath.com.